Alright, so we are going to now solve the last few questions of the test paper, question number 16 to question number 22 of June 2018 2H paper. Right, so the question here is saying that R is proportional to T squared. The graph shows the relationship between R for T is greater than or equal to 0, less than or equal to 4. So let's start off by doing R is proportional to T squared, or I can write R is equal to K T squared. Now if I get one set of value for R and T, I can find out the value of K. So let's say when T is 2, R is 10. So I can substitute these values. 10 is equal to K times 2 squared, or 4K is equal to 10. K is 10 divided by 4, 2.5. So find a formula for R in terms of T. I can write it as R is equal to 2.5 T squared. That's the first part of the question solved. In the second part, they're asking us that given that R is equal to 8 over 5x, show that T is inversely proportional to square root of x for T is greater than 0. So we already found out that R is 2.5 T squared. So what I'm going to do is I'm going to write down 2.5 T squared is 8 over 5x. Now this 8 over 5x, I'm going to multiply both sides by 5. So if I multiply both sides by 5, what I'm going to get is 12.5 T squared is equal to 8 over x, right? Now I'm going to write the 8 over x like this. I'm going to write it as 1 over x times by 8, and I've got 12.5 T squared on this side. Now I'm going to divide both sides by 12.5, so I will get T squared is equal to 1 over x times 8 over 12.5. Okay, so this time I'm going to square root on both sides, so I'll get T is equal to 1 over square root of x multiplied by and if I square root 8 and 8 over 12.5, I will get 4 over 5. So if I write it in a simplified form, I can write T is equal to 0.8 times 1 over square root of x. Now this 0.8 is a constant, so T is inversely proportional to square root of x, and that is proved. Okay, so we move on to the next question. Here we have got a differentiation question, dy dx of x cubed minus 2x squared minus 15x plus 5. So if I do dy dx, that x cubed becomes 3x squared. This will become minus 4x minus 15. So you write here 3x squared minus 4x minus 15. Now C is the curve with the equation y is equal to x cubed minus 2x squared minus 15x plus 5. Work out the range of values for x for which C has a negative gradient. Now you see, when you differentiate something, that gives you the gradient function. So 3x squared minus 4x minus 5 is the gradient function. We need to find out for which values of x this has a negative gradient. In other words, it is less than 0. So I'm going to start off by writing 3x squared minus 4x minus 15 is less than 0. Okay, so if I factorize that, I will get 3x squared. Now 3 times minus 15, 3 times negative 15 is negative 45. I'm looking for two numbers. When you multiply, you get negative 45, but when you add, you get negative 4. In this case, you will get negative 9 times 5. You add them, you get negative 4. You multiply, you get negative 45. So you get negative 9x plus 5x. Now, when I factorize it, I get so I will get x minus 3 and 3x plus 5. Now, if that is equal to 0, then the values of x will be x, you will get 3, or x will be equal to, okay, 3x will be minus 5, x will be negative 5 over 3. But this is not equal to 0, this is less than 0. So the values of x will be within a certain range. And that range is going to be x has to be less than 3, x has to be greater than negative 5 over 3. Okay? So that is a 6-mark question solved for you. Next question, question number 18. A triangle has side lengths of 8, 10 and 14 centimeters. We need to find out the largest angle of the triangle. So let's sketch the triangle. So we've got 8 centimeters, 10 centimeters and 14 centimeters, right? Now we need to find out the largest angle of the triangle. We know that the largest angle of a triangle is opposite the longest side. So I'm looking for this angle over here. Let's label the 3 sides and 3 angles of the triangle. So this is capital A, this is capital B, this is capital C, that's small b, small c and small a. So I can say that a square is equal to b square plus c square minus 2bc cos of a using the cosine rule. What I'm going to do now is I need to find the angle. So I'm going to rearrange the formula. I'm going to write down 2bc cos of a is b square plus c square minus a square. Cos of a is b square plus c square minus a square over 2bc. Now I'm going to put the values of a, b and c. Now b is 10, so I'll do 10 squared plus 8 squared minus 14 squared over 2 times 10 times 8. Now cos of a will give you, if you simplify that, you get negative 1 over 5. Okay, because 10 squared plus 8 squared minus 14 squared gives you negative 32 divided by 160 is negative 1.1 over 5. So value of a is going to be cos inverse negative 1 over 5, and that will give you 101.5 degrees, correct to 1 decimal place. 101.5. So the answer is 101.5 degrees. Question number 19. Triangular prism. They have given us certain lengths. AF is 10. AF is 10. AB is 24. AB is 24. BC is 8. FAB, angle FAB is 90 degrees, and angle BCD is also 90 degrees. And so is angle ADC. We need to find out the size of the angle between the line BE and the plane ABCD. So what I'm looking for here is the angle between the line EB and the line plane ABCD. So what I'm looking for is I'm looking for this angle over here. Now to find out this angle, I need to know, now this is also a right angle triangle because ED is perpendicular to the plane ABCD. So that angle is a 90-degree angle. So we need to find out the angle EBD, but for that I need one more side. I already know that ED is 10 centimeters. ED is also 10 centimeters because AF and ED are equal. So before I find out the length of BD, I'm going to use Pythagoras theorem to find out use the length BA and AD. So let's look at this triangle here. I've got if I have a triangle, I'm talking about the base. Okay, so that's AD. I'm talking about ADB. So AB is 24 centimeters. AD is the same as BC, which is 8 centimeter. I'm looking for the missing side. So for this one, I'm going to use Pythagoras. So BD squared is 24 squared plus 8 squared, which will give me 640. So BD is square root of 640. It's 8 root 10. We'll keep it in the third form for now, right? Because I don't want to round it up too early. So leave it as the third form because that is not my final answer. I just found out the exact length of BD in terms of thirds. Now I've got my second triangle, which is triangle EDB. BD I just worked out is 8 square root 10 and ED is 10 centimeters. I'm looking for this angle, right? I'm looking for the angle over here. So if I use SOHCAHTOA, push it up a bit, SOHCAHTOA, this is the opposite side, this is the adjacent, and that's the hypotenuse. So I'm going to use tan, opposite over adjacent. So I say tan, let's call that angle theta. Tan of theta is 10 over 8 square root 10. So theta must be tan inverse 10 over 8 square root 10, which is going to be 21.56 degrees. 21.56 degrees. It says 1 decimal place, so I can write it as 21.6 degrees. Okay? Right, next question. Histograms. Now in histogram, we know each of the bars, the area of each of the bars represent the frequency. So I am going to find out the area of these two bars. The reason I have chosen these two bars is the question is telling you that 6 of these babies have a birth weight less than 2.5 kilograms or greater than 4 kilograms. So this rectangle and this rectangle represent 6 children. So let's see how many small squares are there. Now from here to here, from 2 to 2.5, there are 5 squares, and you've got 4 squares here. If you count them, you can see there are 4 small squares. So between 2 to 2.5, the number of small squares is 4 times 5, that is 20. and between 4 to 5, you have got 1 square, 1 times 10 small squares, which is 10. So these 30 small squares is representing 30 small squares represent 6 babies. Okay, now let's find out how many small squares are between 2.5 to 3. So between 2.5 to 3, you have got, again, 5 times 4, 20 small squares. Between 3.5 to 3.4, between 3 to 3.4, you have got 4 times, let's see, we have got up to here is 10, 20 is 80 squares. Now, between 3.4 to 3.6, I have got 2 times, that's 10, 20, 25, 50 squares. And between 3.6 to 4, that's 4 times 15. That is 60 squares. So altogether I'm getting 100, 150, 210 squares. So we not see how many babies does that represent. So 30 small square represent 6 babies. So 210 small squares will represent how many? So if I do 30 times 7, it's give you 210. So I do 6 times 7, that will give me 42 babies. So your answer is 42 babies. I'm going to pause for a minute. Okay, so let's get back to our question. Question number 21, surds. So in this question, they said square root of 45 plus square root of 20 is 5 square root 5. So what you need to do is you have to simplify the surds. 45 can be written as 9 times 5 plus 20 can be written as 4 times 5. Now you see 9 and 4 are both square numbers, so you can square root them and bring the square roots outside the square root sign. 3 root 5, 2 root 5, these two are like terms, so you can add them. 5 root 5. Okay, express 2 over 3 root 3 minus 1 in the form of p plus square root of q. In this case, first we are going, where p and q are integers, so first we are going to rationalize the denominator. So you do 2 over square root of 3 minus 1 multiplied by square root of 3 plus 1 square root of 3 plus 1. Why? When you multiply square root of 3 minus 1 by square root of 3 plus 1, the denominator will be relieved of the square root sign. The concept we are going to use here, we are using here, is difference of two squares. So in the numerator, I will get 2 square root 3 plus 2. In the denominator, I will get square root of 3 squared minus 1 squared, which is 2 root 3 plus 2 over 3 minus 1 over 2, which will give you root 3 plus 1, because you're dividing the whole of the numerator by 2. So if you want to write it in the form of p plus square root of q, you can write it as 1 plus square root of 3, where p and q are integers. Then the third part of the question, you have to use the concept of completing the square, because this is clearly shown here in this example, the format they're asking for. So we'll complete the square here. I'm going to open two sets of brackets. So x squared plus 6 root 2 will be written as x plus 3 root 2, and I'm going to write 3 root 2 here. And the minus 1 is not part of the completing square process, so you leave it separate. So you've got x plus 3 root 2 all squared minus 18 minus 1. Your final answer, x plus 3 root 2 squared minus 19. Okay, now we come to the last question, question number 22. Now in this question, we have to use the concept of intersecting chords theorem. So I'm going to do some constructions here. If I extend this line, right, that becomes the diameter. So what I'm going to do now is I'm going to work out between A, B, and let's call it DP. So if I take these two lines, AB and DP, and use the formula for intersecting chords theorem, let's call this part small p, and this is P plus 2. So I can say PF multiplied by DF is equal to AF times BF. Yeah? So PF is P plus 2 plus P. And DF is 2. AF is 7 and BF is 4. So if I simplify that, I get 2P plus 2 times 2 is 28. Divide both sides by 2, so you get 2P plus 2 is 14. Okay, let's write down divided by 2, divided by 2. And if I divide both sides by 2 again, I get P plus 1 is 7. So P is 7 minus 1, 6. So that part is 6 centimeters. So this part will be 8 centimeter. So the radius of this circle is 8 centimeters and the diameter is 16 centimeters. Okay. So this is going to be important. We're going to use this information to work out the value of x. Now what I'm going to do is I'm going to extend this line and I'm going to call it Q. So again I'm going to use the intersecting chords theorem where the chords are meeting outside the circle, right? When the chords meet outside the circle, we call them a secant. Anyway, so what I'm going to do, I'm going to use AC and QC. So I'll start with QC. I can do QC times EC is AC times BC. Now, what is QC? Look, QE is the diameter. QE is the diameter. Which is equal to 16, and I'm adding x to it. So QC is 16 plus x multiplied by EC is x is equal to AC times BC. AC is 7 plus 4 plus 5. You see, AC is 16 times BC is 5. So I'm getting here x squared plus 16x, and I'm getting 80 on this side. Bring everything to this left side, so I get x squared plus 16x minus 80 is equal to 0. Right? I'm going to use quadratic factorizing. Two numbers multiplied together giving you minus 80. When you add, you get positive 16. So minus 80 can be written as 20 times negative 4. So I can write it as x plus 20 and x minus 4 equals 0. So I can write x plus 20 equals 0. X is equal to negative 20. This is something I'm not going to accept because length is not negative. So I'm going to use the other one. X minus 4 equals 0. So x is equal to 4, and that is your answer. So that's all, and question number 23 I have uploaded in a separate video file. So hope that was helpful, and we have got more test paper solutions coming up. Thank you very much for watching.